This is the design of experiments with Dylan Kline, Michael Vogel, Josh Brock, and Kaiqi Li, and we are Benign Engineering.
Hi, my name is Kaiqi Li, and I am doing the video editing.
My name is Josh Brock, and I did the data measurements.
Hi, my name is Dylan Kline, and I did all the data recording and did the presentation.
Hi, I'm Michael Vogel, and I threw the darts.
What we are testing. We are testing the effect of throwing rate and distance from dartboard on the distance of the dart from the center of the board in order to minimize it.
We chose to do this experiment because it is very accessible, since most people have played darts at least once in their lives. Since this is a common bar game and betting game, it could mean the difference between winning and losing money. It could also be used for carnival games, sports arenas, and so on if the goal was to maximize the distance from the center, so as to decrease the chance of winning a game and losing money for a business.
The throwing rate is going to be altered because we believe that it would be better with more time to analyze results from the previous throw and make changes for the next one. However, muscle memory also plays a large part in this if the previous throw was good. The time would be measured with a metronome going at 60 beats per minute. The distance from the dartboard is another factor we chose to vary since it requires more power to simply put the dart on the board, which could throw off aim. In addition, if the aim was perfect before the throw, gravity changed the predicted trajectory. This was measured using the dimensions in a room of Arbol de la Vida, and a halfway point was measured using a ruler. Then the thrower placed his back foot on the line that we measured to throw.
We predicted that the low throwing rate, low distance from dartboard combination would yield the minimum distance from the center of dartboard when throwing, because it allows the thrower to think about where he is throwing, and the low distance means minimal interaction with gravity, so that trajectory is somewhat near where it should be.
As you can see, Michael has enough time to correct his mistakes in his mind, but if his previous throw was good, his muscle memory is diminished and therefore can't take that into account. This is what the dartboard looks like. As you can tell, the darts are closely bunched together in both experiments, but neither are really close or on the center. The average distance from the center for our first trial was 4.74 centimeters. The standard deviation was 2.08.
Here, Michael's muscle memory comes into play, as you can see. All of his throws are practically identical. The result of his muscle memory taking effect can be seen here. Usually the darts are bunched together within the same area. Therefore, when he makes a good throw, he is rewarded by a consecutive good throw. However, bad throws cost him tremendously. The average distance from the center for our second trial was 4.25 centimeters, with a standard deviation of 2.31 centimeters.
Although you can't see the dartboard here, I have to put extra effort into the power the dart is being thrown with just to get the dart to the board. Again, though, I have plenty of time to think about my next move. The first 5 darts demonstrate gravity's effect on my predicted trajectory. In addition, the spread is pretty large as a result of me having to think about my next move. Here you can see the average distance from the center was 9.4 centimeters with a standard deviation of 3.59.
Michael's muscle memory is exhibited here again with a higher throwing rate. Each throw is practically the same. Again, as seen in the first test with a high throwing rate, the darts are in pairs close together. The average distance from the center is 10.6 cm. The standard deviation is 3.41.
The grand average distance for all of the dart throws was 7.2475 centimeters, measured from the center of the dartboard. In addition, the optimum level for throwing the dart with a minimum center from the dartboard was a low throwing rate consisting of 4 seconds per throw and a low distance of 70 inches.
As seen in the graph, the distance has a very large effect on the accuracy of the thrower.
Using the results from the prediction equation, we then had a trial to verify the optimum levels for throwing the darts while trying to minimize the distance from the center. This meant throwing 70 inches away and 4 seconds per throw. The average distance is 4.43 centimeters, and the standard deviation is 2.5.
Did it work? Of course! However, there were a few possible errors. Timing was a small error. Some darts fell off because they collided with each other, so we estimated where they landed. Also, since we had a limited number of darts, the time in between could have given the player time to analyze the first set.
It seems that the change between the high and low levels of the throwing rate meant on average 0.355 centimeters from the center. With that being said though, the change between the high and low levels of the distance from the dartboard meant roughly 5.505 centimeters on average from the center of the dartboard. Clearly, the distance from the dartboard has the greatest effect on the distance from the center, whereas the throwing rate has very little effect.
Overall, we determined that the low throwing rate combined with the low throwing distance yielded the best results as far as minimizing the distance from the center. DOE allowed us to consider all of the possible variables when designing the experiment and let us see what the effect of each variable was.
Future studies could be done to see if magnetic darts or real darts yield better results. Height of thrower affects results. Gender affects results. 无聊。